Okay, I have welded the motors, the stepper motors, alongside on one side of the foot part. I have allowed it to be a biaxial for the toe and for the other part of the foot. And these are for the bearings. I'm going to apply these bearings. I'm going to cut the center down. I have four stacks of wood pieces. I'm going to cut it down and wrap a winding coil with inside of here and apply on the top of the frame a wafer block aluminum, and on the bottom of the frame a wafer block aluminum. But between there, it's going to be a winding coil, and that it's going to go on top of here. Now I have the cuts for alongside, so I can wrap the winding coil and exchange it from over here and over here and over here. So I can only leave this armature out, sticky, not touching locally near the coil. Before I apply the coil, the procedures, the process of using the thermoplastic sheets. Cutting out the thermoplastic sheets, applying thermoplastic melt over it, heating it up, and allowing it to allowing it to saturate over it, so it can be from the non-conductive surface. And then I'm going to add the piezo buzzers alongside within the thermoplastic. I'm going to put one sheet down first, then I'll follow it up with another sheet. And the other sheet that I followed up with, one sheet that I put down, I'm going to apply the piezo buzzers and connect the bus bridge by copper flat bars, and connect the piezos together. And then what I'm going to do is put another thermoplastic sheet melt over it, over the piezo, to protect the piezo with inside. Then I'm going to add the permanent magnets localized alongside the motor. So I'm going to put a wafer at the bottom on top of the thermoplastic and put another thermoplastic melt over the permanent magnets. It's going to be nickel beam, and they're going to be localized around the base of the armature, so they could be extended around the base, localized within the center of the circular. So while it rotates, the copper coil rotates, not receiving any induction, but only from the permanent magnets that are going to be localized on the side, and the electromagnetism that is going to be wrapped within the thermoplastic, which is just using thermoplastic, thick thermoplastic melt, and wrapping it with a winding coil, then laying it on the surface, making a whole space so it fits like a shoe. So it's like taking a piece of paper and wrapping a winding coil around it in a dentil, folding the end so that it curves directly around it in a proper helix shape. Then taking the sheet and applying it to the surface, heating it with a light heater, microwave, not a hot blower, and allow it to saturate with it on the surfaces. So there to be a linear motor moving forward. So sectioning the parts, so these sections allows it being biaxial. Then apply the permanent magnets alongside on top of the surface. So the electromagnetism, the electrical energy has been energized within the system through the copper coil. And I use a single rectifier, phase, one-way phase rectifiers, which allows the input to go one way, the current to carry one way, and not go back up the other way. And add capacitors, to the induction coil as a bypass between it, so that the current that is received through the permanent magnets will synchronize within the wafer and increase the voltage of the wafer, having the ends of the coil of the wafer bearing one-way rectifier, so facing the opposite direction towards the coil, so it doesn't leave outside of the coil. Then I'm going to have ultracapacitors to bypass it, so it maintains the current being synchronous charge by the permanent magnets are localized, and that will cause, by rotationing, phasing this with eddy currents, phasing the diamagnetic with eddy currents, and causing it to lift up in the air. That procedure dissipates more heat than having the direct DC current phase to the induction wire, or spool, solenoid coil, or magnetic suspension coil, which is better than the direct current. It's better for a synchronous current than direct current. So I'm using that right now for this system. I'm still going to maintain the palletary modules and allow the modules to saturate also between the unit on the other side. So I'm still going to be using heat sinks. I'm still going to be using a double aluminum to overlap the board. So notice I fix within the board, so it's not that high in size. It's not that bulgy in mass. So I'm keeping it thin as possible. And starting off with this, and I'll see what I can work out with this before if these things can be implemented and incorporated into a device, wearable, flyable device that can articulate with the human biometric range, biaxial or wrong. So that's what I'm trying to do, is pinpoint the areas that are going to be amplified or as extremity, and modification of my biometric range, foot range, in this segment. So my name is Ray Morton. Have a nice day. Goodbye.